This is CPE 133. This is experiment 12. Yet another finite state machine based circuit. And what we're going to do in this experiment is generate a Fibonacci sequence. Objectives, of course, to gain more experience with finite state machine controlled circuits. And the quick description, very simple. Design a circuit that generates the Fibonacci sequence. So it's a little bit unique, and I think it generates the first 16 or 17 values in the sequence. So it generates them going upwards, and then it degenerates them by going downwards. So there's a display in the next slide on this. So you're only required to visually verify the operation works properly, although you may want to use the simulator to debug your circuit. So this is the sequence as it should be. This is what the display output should be on this line right here. So it starts at 0, maxes out at 987, which I think is the 17th character in the sequence, and then it starts back down in the reverse order. These numbers are going to be displayed on the 7-segment display on the development board, which means you're going to need to use that universal 7-segment display device. So the constraints are limit the number of states in your state diagram to 8 states or less. No big deal. It's very doable. And I don't want you to use any more than 2 pure registers in there. That's pure register. That doesn't include counters or shift registers or however else you want to do it. So this is a relatively simple circuit. Once you get over the initial conceptual challenge of it, it has actually a very small finite state machines, very few number of states in this circuit. Not a big deal. It's just a little bit tricky when you first look at it, but it turns out to be a relatively simple circuit, and it's very easily testable visually. If you have problems, well, you're going to have to check it out in the simulator, but it shouldn't be a big deal. So once again, design this on paper first. I would start with a circuit and then go switch over to a state diagram that controls that circuit. You're not required to simulate this circuit, but it certainly is a viable debug tool to help you get this circuit working. Essentially you can kind of visually see what's going on, but oftentimes it's just easier to write a quick test bench for this and see what's happening. And the test bench is very simple. Essentially you just turn the go signal on, and then, or the button press signal, and then watch the output of whatever. So watch the input to the universal 7-segment display driver. Now the issue is universal 7-segment display driver has a clock divider in it, so you're not going to be looking at the output of that clock divider because it's pretty slow. There are other comments in the lab manual. Be sure to see those also.